vocab real quick, lesson 1-1. Collinear points. Like I said, geometry is going to be a bunch of new things that you haven't heard before. Okay, this is kind of where it starts. What do you think collinear stands for? Or what do you think it means? Do you know a part of that word?
Linear.
Linear. What do you think of when you hear linear? A line. Okay, so what do you think collinear means? It's not two lines.
More than 2 lines.
If I draw a line here,
No lines.
collinear points mean 2 points on the same line. Yep. 2 points on the same line are collinear, or any points on a line are collinear to each other. Okay? A line, we all know what a line is. What do we think a plane is? It's not an airplane. The graphs, okay, that can count as a plane. Okay, in geometry, a plane stands for just a part of space. Okay, so if I put a point here, is that on the plane? Yes. Is this point on the plane?
No.
No. Is this line on the plane?
Yes.
Goes through it, so technically is part of it on the plane?
Yes.
Yes. Is this line on the plane?
No.
No. Do we understand what's on and off the plane? Okay. Point, we know what that is. What do we think postulate means? Start with this. Do you know what theorem means? A theorem is just a statement that proves a fact. Okay? We're going to use theorems or different properties of things in geometry so that you know them. Okay? And we'll go through those all year. Okay? So, back to your explore. What did you guys say for A? What are methods that you can use to find the distance? Subtraction. I heard count. What did you say over here? Addition. Okay. Want us to think about the subtraction and addition. One of them's right, one of them's wrong.
Addition's right.
Wrong.
Let's think about it. If I add 5 plus a negative 3, what is that? 2. Are these two distances apart? No. How many are they? 1, 2, 3, 4. It is 8. Okay, mark that in here. Can I count A? Like, can I start this as 1?
No.
Why not?
Because it's not one.
Because I'm not moving, right?
Yeah.
This is technically our 0 point. So then we go 1, 2, 3, 4, 5, 6, 7, 8. So you can count, but can it be addition? No, it would have to be subtraction. If I go 5 minus a negative 3, that turns into
8.
5 plus 3, which is 8. Can I go the other way around? Negative 3 minus 5. What's negative 3 minus 5? Negative 8. Is that close to 8? Is negative 8 and 8, what's the one difference? The negative, right? How? Back up. Can distance be negative?
No.
Why not?
Well,
You're right, it's no. Why can't distance be negative?
You have to measure something.
Right, you got to measure something. It's not going in the negative direction ever. Okay? So with our negative 8, how can I change that into a positive? Think of jail bars.
multiply by -1.
That would change the value. I want to do something without changing the value. Absolute value. So if I have a negative 8, remember these jail bars, what do those do? Makes it positive, which turns it into 8. Okay, so we want to use subtraction, and you can do it either way. Just remember, if you get a negative, remember you can't have negative distance. So it just has to turn positive. Okay? Which method's easier, counting or subtraction?
Subtraction.
Okay? For this one, how many of you counted it right away? Right. If you had point A all the way over here, point B all the way over there, would you want to count all of those?
No.
No. That's when you would use subtraction. Okay? Let's look at these. These are not in your notes. Okay? If you ever want... Okay, we've already talked about some of these things, but a point is just a dot. That's a point. A line is that it goes through 2 points. Notice a line has arrows on both sides. Okay? And then a plane, we already talked about it. It's a partition of space. Okay? Here, we talk about segments. Why is this a segment and not a line? What'd you say? Not infinite, which means there's no arrows. Segment has 2 stopping points. It has 2 endpoints. Okay, so that's a segment. What's the difference between that first picture to the next one? There's only one endpoint. What do you notice goes on this way? It keeps going, right? Arrows mean infinite. Okay, what about the opposite rays, that third one? How many rays make up that line? 2. What's the starting point for both of those? T, right? If I'm here, I have a ray going this way, and I have a ray going this way. So a ray has a starting point, and then it goes on forever in one direction. Okay? Angles, a little different. We can name an angle 3 different ways. Okay? Why did they pick Q to name the angle and not P and R? Why did they pick Q?
It's the vertex.
It's the vertex. It's our middle point in that angle. It's where that angle is. Okay? Vertex is awesome. It is called the vertex. Okay? Same thing, similar with angle 2. That's just what they put in there to name it. Okay? What about this one? Does the order matter? If I go P, Q, R, can I go P, R, Q? Why not? The vertex or our center point has to be in the middle. Can P and R switch places? Yes. Okay, but just make sure the vertex is always in the center. Okay? All right, we'll get into some examples. This is on your notes, correct?
Yeah.
Okay. So, find the length of CD. They already did that for us, which is 3. Okay, what does it say on your notes it wants you to do? Figure out what AC is. Okay, so AC is here. What are the 2 ways you can do it? Subtract or count. What do you get when you do either? AC, remember, start here. Go 1, 2, 3, 4. So let's do more practice. We just found AC was 4. What if we have a ruler? How is a ruler similar to just a number line? Do you think they're similar? What do you use a ruler for? To measure something, right? Kind of the same thing of a number line, using it to measure segments. So it's used for the same purpose, okay? So it tells us coordinate x is 3 and coordinate y is 7. How can I find the distance between those two? Subtract or count. What's the difference? It is 4. What if I got -4? Am I right? No. What's wrong with it?
This would be positive.
Has to turn positive, so we use those absolute value bars. Okay? Now that example in your notes, you got this, right? Yeah? Okay. How can we find JK? 2 ways, right? Subtract and or count. What do you get?
7.
Does everyone agree with 7? Okay. Again, remember, you cannot count your starting point. Do not count this as 1. You have to move 1, 2, so on and so forth. Okay. What about KM? I heard 15. Are we in agreement? Okay. What do you notice about K to M? What's in the middle of them? L. Does that matter? No. Okay. But what we're gonna learn. Do you agree? KL plus LM equals KM. Okay, cool. Questions about ruler postulate? We're all right? Okay. When we get to here, this is what we just realized on the last example. Segment addition postulate. Again, what's a segment? A line with endpoints. Okay, so AC is made up of AB plus BC equals AC. Remember when I said algebra is going to come into play? This is how we use algebra to help us figure out what segment lengths are. Okay, so remember, if you have 3 points, remember 2 of those segments can make the other one. Okay, so let's look at this one here. In geometry, you always want to use what you're given. In geometry, there's a lot of pictures. Okay, so on this one, it says GH is 16. So I'm going to find GH here to here. That is 16. Okay, you guys don't have this on your paper yet. It wants us to find FH. Is FH the whole thing or is it a part? FH. That's the whole line, right? Okay, so how do we use what we're given to find the whole thing? Notice we have algebra expressions in there, right? What's the main goal? What'd you say?
On both sides and then add them together.
Find both sides and add them together. So when we have algebra in there, we normally want to find the value of x, right? How can I use what they gave us to find the value of x? We have to find x first. We know that 2x plus 2, I'm going to come over here. We know that 2x plus 2 equals 16. Now that's an algebra equation, right? How do we solve it? Subtract 2 on both sides. And then we divide by 2. X equals 7. Is that the answer that we wanted? What does it want us to find?
The other side.
It wants us to find FH. In order to find FH, what else do we need to find? We have to find FG. What did you say?
Put 16 with 3x minus 1 also? Or
Put a 7.
Close.
Put the 7.
We found x. How can we use x to help us?
Put 3x minus 1.
Yep, a lot of you are saying it. We're going to plug x here into 3x minus 1. So watch. When I plug in a number, does that turn into 37? No, right? You need the parentheses. 3 times 7 is 21 minus 1? 20. Okay, is that our answer? No, what did that just give us? That gave us the other half. So how do we find the whole now? Add them together. What do we get? Good. Okay, what did I always tell you to do first? Draw. Use what they're given. What did they give us in A? What is 25? J and L is 25. Mark it. This whole thing right here is 25. Okay? Remember that segment addition postulate we talked about? Okay? It wants us to find n. In order to find n, we have to set up an equation. So how can we set up an equation with what they gave us? What?
Add the two bottom.
Yep. We want to add our two segments together that make up JL and set that equal to 25. So what that'll look like is 3n, I don't like red, 3n plus 5n minus 7. So what I did is I took these two, I added them together. Okay? And then in order to solve for n, we have to have equals something. What does it equal?
25.
Yep, the whole thing equals 25. How do we solve this? Combine like terms first. What do we have as like terms? 3 and 5 gives us 8n minus 7 equals 25. What's next? 2 more steps.
plus 7 over, make it a positive.
Yep, plus 7. 25 plus 7? 32. Last step. Divide by 8. N equals 4. Did we answer A? Yes. A is done. Now we need to use, or look at B. Did we find this for no reason? No. Once you find N, you're probably going to use it. Okay? So if it wants us to find JK next, JK is right here. How can I find JK using N? Plug it in, right? So I have 3, is it 34, or what is it?
3 times 4.
3 times 4, which is 12. Okay, so this right here is 12. There's a couple different ways I can find KL. What's one of them?
You could subtract the 12 from the 5.
Right, I could plug it in just like we did, or I can use what we have now. How do I find this missing piece? Subtract them, right? 25 minus 12, that gives us 13. Could you have still plugged it in and get the same thing?
Yeah.
Yes. Okay. That's angles. Okay, does anyone know what that tool is? Someone said it. It is a protractor. Okay. Does anyone know how to read a protractor? To find an angle measure. What's an important part of an angle? What did we say? The vertex, right? That center point. What's our vertex on this protractor? B. Okay. B is our center point or our vertex. How can I find A, B, C? How can I find the measure of this angle right here? A to B to C. Notice the numbers are out here. So we need to see how long or how wide this is right here. So this is 0 right now. Does everyone agree? We're at 0. And I'm taking C and I'm going this way. Where does it stop? 60. Notice there's 2 numbers here. Right. The bigger number on the bottom is if you went the other direction. Okay, so this right here, ABC, is how many degrees? 60 degrees. Good. What about ABD?
0. Oh no, it's
So remember, if you think about it, to get to D, I'm coming all the way this way.
180.
180. Yep. What about CBD?
120.
It is 120. Why is it not 60? Because that would be the other way. Yep. Questions about how to read a protractor? Okay, try that example in your notes. Let's look at these two examples. Your first one was AEC. I saw you, some of you drawing it, which is awesome. Okay, we want AEC. Okay, so we want to know the distance from here to here. What is it? It is 105. Does everyone agree? Yes. Okay. What was the other angle it wanted you to find? BED. Is that what it was on your notes? BED. Is this one as easy as the first one?
No.
Why not?
Because you gotta subtract.
Why do we have to subtract?
And it's not on the bottom.
It doesn't start at 0, right? It doesn't start at 0, so we have to subtract just like we were with our number lines, okay? So what is the number on right here? 130 minus, let me come down here. 130 minus, what was this one right here?
I did 46.
46, 47, I'd accept both, okay? I'm going to say 46. So I take 130 minus 46, what does that give you? 84, or if you got somewhere around 84, that's fine. Okay? Could I have done 46 minus 130? 46 minus 130?
Yeah.
What does it give us?
Negative 80.
Negative 84, but can we have a negative angle measure? No, so it would be absolute values to give us that 84. Okay? Questions about today?